phosphorus, the allotropic forms. Let us study the allotropic forms of phosphorus first. It shows many allotropic forms, and out of which the three allotropic forms, red, white and black, are most common and important. Let us first discuss white phosphorus. The phosphorus which is when obtained from the calcium phosphate is basically white phosphorus. It's a waxy solid, insoluble in water, but soluble in the organic solvents like carbon disulphide, CCl4, etc. It is basically having independent P4 units in which each phosphorus is bonded to 3 more phosphorus atom, and they are arranged in a tetrahedral manner. Each is having 1 lone pair. Now, since each angle, all the angles are equilateral, are in the part of the equilateral triangles and are of a 60 degree, it has high angle strain. As a result, it is the most unstable form of allotropic form of the phosphorus we are having. It's very reactive, very easily catches fire when exposed to air, and when exposed to air, it combines with oxygen, catches fire and forms P4O10. So very easily. The reason being because of the large angle strain. It's very unstable. Remember, it's translucent waxy solid, and it is soluble in NaOH. When dissolved in NaOH solution or when treated with NaOH solution, it basically shows disproportionate reaction and forms phosphine and sodium dihydrogen or sodium hypophosphite. In this phosphine, it is having -3 oxidation state. In hypophosphite, it is having +1 oxidation state, and from 0 it is changing into both oxidized as well as reduced state. So it's a disproportionate reaction. This is also one of the preparations of the phosphine gas we are having of the phosphorus. Now, this white phosphorus is, as I have told you, is unstable because of the large angle strain. Now, let us move to the next one, red phosphorus. Red phosphorus is formed when white phosphorus is heated at around 300 degrees Celsius under pressure. It changes to red phosphorus. Red phosphorus is comparatively more stable. Is more stable than the white phosphorus. The reason being because it consists of these type of polymeric units of P4 units. Since they get stretched to this side, angle strain is less, and that is why it's more stable than the white phosphorus. There is one more property which distinguishes these two allotropic forms. It glows in the night, it shows chemiluminescence, whereas red phosphorus doesn't show chemiluminescence. Due to the lesser angle strain, as I have told you, this is more stable than the red phosphorus, white phosphorus, and this is how it is prepared. This red phosphorus is insoluble in water as well as in organic solvents like carbon disulphide, etc. Now let us move to the next allotropic form of phosphorus, which is called the black phosphorus. Black phosphorus exists in two forms, alpha and beta. Remember, when red phosphorus is heated in a sealed tube at 803 Kelvin, what we get is alpha black phosphorus. This alpha black phosphorus is very inert, very stable, and it doesn't show any type of reactions, and at a very high temperature. And that is why what we say thermodynamically the most stable allotropic form of the phosphorus is this alpha black phosphorus. Similarly, when this red phosphorus is heated at around 200 degrees Celsius under a very high pressure, it changes to another form which is called beta black phosphorus. This beta black phosphorus doesn't oxidizes till a temperature of around 400 degrees Celsius. So this is how these are its three major allotropic forms.